Algebra students, in this lesson we are going to solve the second easiest type of equations in all of algebra. Now remember, there was a previous lesson where I said we were going to be solving the easiest type of equations. I introduced that lesson by talking about what equations are. They have an equal sign in them. We can do the same thing to both sides of an equation and still keeps the equality true. And in those problems we were doing one step, and they were addition and subtraction problems. Easy, easy, easy. This lesson is almost just as easy, except we're going to step up our game a little bit, and instead of just doing addition and subtraction, now we're going to be doing multiplication, division, but they are still one-step equations. Easy, easy. I don't think you're going to have any problems with this. Let's get started. Now, here's what you need to remember. I told you this in that previous lesson too. Whenever you have an equation, to solve the equation, you need to get the variable on a side by itself. To get the variable on a side by itself, you need to use inverse operations. If there's something being added to the variable on one side, you need to subtract that thing from both sides, get the variable by itself. Today we're going to learn that if there's something multiplying a variable, you need to divide both sides by the thing that's multiplying the variable. If there's something dividing a variable, you need to multiply both sides. And remember, all division is actually multiplication of a fraction. We're going to be dealing with some fractions today. If there's a fraction multiplying your variable on one side, you need to multiply by an inverse fraction. That's the inverse operation, okay? You need to multiply by an inverse fraction to get rid of that fraction. We're going to be dealing with all of that in this lesson, so stay tuned. First of all, just want to point out, there is a multiplication and division property of equality, the same as there is an addition and subtraction property of equality. The addition and subtraction property stated that if you do the same thing to both sides, okay, so for the addition property, if you add the same number to both sides of an equation, the equation will still be true. If you subtract, that was a subtraction property, if you subtract the same number from both sides, the equation will still be true. Multiplication is the same. If you multiply both sides of an equation by the same real number, the statement will still be true. Notice what's going on here. 2 equals 2. 3 times 2 equals 3 times 2. I multiply both sides by the same thing. What do I get? 6 equals 6. Still true. Here, if we use A and B instead, as long as I multiply both sides by the same number, I have an equivalent equation. Division works the same way, but there's one important rule in division. Technically, it's an important rule in multiplication too, but the thing is, in multiplication at least, our equation is still true. There's something you can never do with division. There is a rule that you can try to break with division, but you're not allowed to. Okay, we'll talk about that in just a second. But the division property looks similar to the multiplication property. If we divide both sides of an equation by the same number, the equation is still true. 10 equals 10, divide both sides by 2, we get 5 equals 5. A equals B, we divide both sides by C, we get A over C equals B over C, but wait, there's a rule here. C can't be equal to 0. Division is a little broken, okay? There are some rules in division that you have to be sure to follow that you don't have to worry about with the other operations, and one of them is you can't divide by 0. You can never divide by 0, and that is going to come up again and again. You're going to have to stipulate, if you have a variable in your denominator, that that variable cannot equal 0. It is never able to equal 0 in the denominator, because what do you get when you divide by 0? You may think it's 0, but think about it. What's 2 divided by 0? How many times does 0 go into 2? How many zeros can you fit into 2? Now, 0 divided by 2 would be 0. Anytime you have a fraction with a 0 on top, that fraction equals 0. But if you're trying to divide by 0, you run into some problems logically with how you're going to do that. Okay, so that's what this is all about. I just want to point that out. You're going to see that starting now. You're going to see it again and again in algebra. You can't divide by 0. You can divide 0 by other things. 0 divided by 8, 0 divided by 12, all 0. But you can't divide with 0 on the bottom of a fraction or divide by 0. All right, let's take a look at some practice work. These aren't the practice problems yet, but this is some practice work to get us working with how we figure out what to do to both sides of an equation. All right, so what would x be in each of the following cases? 60 divided by x is 1. If 60 divided by x equals 1, what does x have to be? That's the sort of question you're going to be asking yourself as you solve the types of problems you're going to run into in this lesson. Okay, now it's not going to be directly like this. You're not going to be filling in a table with a whole bunch of values like this. But when you see like a number on one side of an equation being multiplied by a variable, let's just uncover this, okay? When you see k being divided by 9, you have to ask yourself, what am I going to do to both sides to get k on a side by itself? How do I do that? We're going to do 2 table exercises here that are going to help us practice how to do that thing, okay? So the first thing that we're going to do is figure out what x is going to be in each of these cases so that 60 divided by x equals what it's supposed to. What is 60 let's see, what is x if 60 divided by x equals 1? Well, I can answer that question pretty simply. If 60 divided by x equals 1, then x has to equal 60. It's going to be 60 divided by 60. Okay? My spacing is going to be different from the stock spacing here, so we'll have to ask, we'll just keep copying and pasting here. What about if 60 divided by x equals 2? What would x have to equal? Well, if 60 divided by x is 2, that means I'm dividing it into 2 pieces in half. I have to figure out how to divide 60 into 2 pieces. I'm going to divide it by 30. If I divide it by 30, 30 is half of 60, and that would be what I plug in there. This is the sort of mental math that you're going to have to do to figure out what to do to both sides of these equations. 60 divided by what is 3? Well, by now you should be getting good at this. 60 divided by 20 is 3, because I need to split it into 3 pieces. 60 divided by what is 4? This one's a little harder. 60 divided by what is 4? Maybe you recognize that 15 goes into 60 4 times. 60 divided by what? 60 divided by what equals 5? Well, I know that 60 divided by 12 equals 5. 60 divided by what equals 6? That one's pretty easy. I know that 60 divided by 10 equals 6. How did I figure this out? 60 divided by some number equals 1, equals 2. Well, I can guess that in the background of your mind, you may not have been thinking that you were doing this, but the way to figure this out is actually just to divide 60 by the number you're looking for. If 60 by something, I get 1. 60 over x equals 1. Well, if I just divide 60 by 1, it tells me what that other number is. If I divide 60 by 2, it tells me what I have to divide 60 by to get to. The point is that fractions are inverses of other fractions, okay? And we use this sort of inverse thinking all the time. The same is true, though, for multiplication. So instead of actually doing this multiplication, maybe what your brain is doing is asking, what do I have to divide 8 by to get back to 4? 8 divided by 2. What do I have to divide 20 by to get back to 5? 20 to get back to 4. What do I have to divide 20 by to get back to 4? 20 divided by 5. 32 divided by 8. 36 divided by 9, and so forth. Okay, so the point is that because fractions are inverses of other fractions and they're related to each other, anytime you multiply a fraction by its inverse, you can cancel that fraction out, and using that trick, you're going to be using a lot of thinking like this, reasoning like this, to figure out how to get x on a side by itself, or m, or k, or y. All right, let's work some of these practice problems and see how this plays out in real problems here. Letter A, k divided by 9 equals 3. What I'm going to do is I'm just going to multiply both sides by 9. K over 9 times 9. So k over 9 times 9. I should probably put this in parentheses too, just to show that it's grouped together. K over 9 times 9 equals 3 times 9. K over 9 times 9 is just going to become k equals 27. All right, letter B. Here we have negative 20. Let's see, negative 20 equals 1 over 5 times m. Now here's the thing about ones like this. Here's a little trick that you can use. Anytime you have an equivalence statement in algebra, You can always flip the thing to the other side, flip both things to either side of the equal sign without changing the expression. So I could write 1/5 m equals negative 20, and that's kind of nice because I always have my variable on the left when I do that. How am I going to cancel out that 1/5? I'm going to multiply by the inverse of 1/5, which is 5. 5 times 1/5 m is just going to be m, because it's given 5 over 5m equals 20 times 5. Multiply both sides by 5. What do I get? M equals negative 100. If I plug in negative 100 for m, I obviously get negative 20. All right, let's do letter C. Letter C, 8y equals 24. Now, I could divide both sides of this by 8. I would get y on one side and 3 on the other. But this one's pretty obvious that y is going to equal 3. How did I get y equals 3? In my head, it's pretty straightforward to just divide both sides of this by 8. Now, can you do that? Can you just not write out divided by 8 on both sides? As an algebra student, you always have to write it out. Show your work, show where your answer came from, because it's by going through those patterns when the problems are easy, it's going to be a lot easier to do them when the problems are hard. Letter D, negative 15 equals 3x. I'm going to be dividing both sides of this by 3. If I divide negative 15 by 3, I get negative 5. If I divide 3x by 3, I get x. Let's go back and check. If I plug in negative 5 for x, do I get negative 15? Check. All right, letter E is a little harder. For letter E, we have 3/4 y equals 11. I'm going to multiply both sides by the reciprocal of 3/4. There's the trick. Whenever you have a fraction times a variable, multiply times the reciprocal. So this is going to be 4/3 times 3/4 y equals 4/3. I multiplied both sides by 4/3 times 11. All right. 4/3 times 3/4 is just going to be 1. These two inverse fractions cancel each other out. 4/3 times 11, well, let's see. I just multiply straight across the top. 11 is the same as 11 over 1. This is going to be 44 over 3. Letter F, 8 equals negative 5/12 n. 8 equals negative 5 over 12 n. Well, let's see, again, I can flip sides of my fraction and get the variable on the left. I like to do that. So negative 5/12 n equals 8. Multiply both sides by negative 12 over 5, by the inverse, okay? That's going to cancel out the fraction on this side because they're inverses of each other. And on this side, I just have to multiply by the same thing, negative 12 over 5. Let's see, this one is a little bit harder to figure out. 8 times negative 12, that's going to be, what is it, 80 plus 16, 96? I believe that's going to be 96. So this becomes equals negative 96 over 5. Go ahead and just leave that in as an improper fraction. It's going to be a negative improper fraction as the answer. And then finally, our last problem. What we're going to do is figure out if a rectangular pool has an area of 140 square feet. The length is 16 feet. What is the width? Well, I know that length times width equals area. I'm going to take 16w divided by 16 and then 140 divided by 16. That is going to be how I solve this problem. So 16w divided by 16 is just going to turn into w because the 16s will cancel. And the width equals 140 over 16. 35/4 is going to be my answer. And if I think this, 35/4 times 16 is going to, just punching this into a calculator on the side here, is going to equal 140. That's the answer. So this is going to be 35/4 of a foot. All right, you are now ready to work problems where you divide both sides by the same thing or multiply both sides by the same thing.